you a couple of the things that you're going to be using tomorrow that maybe you haven't seen, or tomorrow, Monday, that you maybe haven't seen before. All right. How many of you were panicked there when I said tomorrow? Well, I ain't going to be here. I'm going fishing. Yeah. Okay. All right. So first off, depression plate. This is the depression plate. It's not because it's like sadness from like inside out, okay, anything like that. It's just, it has little pits in it, depressions, all right? So now that gives you an idea of how much of each material you're going to be using. Okay? We're going to be dealing with incredibly small amounts of everything. So when you're telling people in the procedure, when you're designing the procedure, you're going to want to specify how much to put in. But we don't want to have to take the mass of everything because that takes forever, okay, to measure out 1 gram of all of this stuff on a scale. It's just not, it's not logical to do that for this lab. So I would suggest that you tell people to fill the depression with each unknown about, let's say, 1/3 of the way, okay? Right, so fill each depression to 1/3 with the unknown sample. 1/3 of this depression will ensure that we have at least close to the same amount of everything, enough that that'll be close enough for having essentially a controlled experiment. Everybody follow there? Okay, and then when we're talking about doing the solubility test, did you get it? No? Okay. When we're talking about doing the solubility test, then you would probably say fill the depression to, don't fill it all the way up. Because if you do, when you put the thermometer in to see if there's a temperature change, which is something you're going to do, okay, then you'll overflow the depression, and then it'll contaminate all the samples around it, and you'll be redoing all of those samples. So fill it 1/3 of the way with the unknown, and then fill it to maybe about 2/3 of the way when you're doing the solubility test. That way, when you put the thermometer in or the conductivity tester, this thing, okay, but that's, it won't overflow and contaminate the other solutions. Everybody follow on that? So a little detail that you probably want to include because it's something I'll be looking for when I mark your procedure. Okay. Then you got your pH paper, okay, Hydrion paper, right? It's just kind of yellowy, orangish green. Depends actually which case you get, what color it starts out as, but each of them have a color chart here. So you stick it in the unknown solution and then compare it to the chart and record the number for the pH. Okay, that one's pretty simple. All right, the conductivity tester, also quite straightforward. Okay, you stick the 2 leads into the depression, like so, and then press the button. Okay, you'll know it's working because it does have an on button. The ones we had before didn't have that, and you couldn't tell whether it was non-conductive or the battery was dead. These are vastly superior. Okay, so just stick it in there and it'll give you a conductivity reading. Obviously right now it's reading nothing because porcelain doesn't conduct electricity. All right. Everybody follow there. Okay. Housekeeping things that should probably be included in your procedure. What should you do with the conductivity tester each time you use it? You should rinse it off. What should you rinse it with? What kind? Distilled. Okay. You'll have little wash bottles filled with distilled water. Make sure you rinse this with distilled water, because if you rinse it with tap water, all the ions that are in tap water will remain on here, okay, and possibly contaminate the next sample that you use. Okay, so rinse it. You can dry it if you want, but you really don't have to. If you rinse it with distilled water, you're not going to contaminate anything by 1 drop of distilled water dropping in. Okay, so little things like that are things that you'll probably want to include in your procedure when you're designing it. Okay, and then like we said, the amounts. We'll also have in the lab like a permanent marker, and you can label each one of these depressions like A, B, C, D, etc. Right? Because if you don't, it'll be hard to remember which one was which. So you'll write those on first. Again, is that something that should be included in your procedure? Label the depression plate. Okay, little things like that. Remember, your procedure needs to be so detailed that any idiot could follow it. Okay, I know it sounds kind of crass, but it's true. Okay, it needs to be that detailed. All right, the tests that we are going to run are going to be the observable properties tests. That'll be the first one. Okay, so once you've got all of them, okay, all of them filled in, okay, then the first thing you're going to do is the observable properties test. That's your basic physical properties, right? So we're looking at things like color, texture, state, okay, smell, right? All those kind of basic things that don't require you to really do anything with the compound except Use your five senses. Well, except touch. Don't touch them. Okay, not with your bare hands. Not that many of them would hurt you, but one or two could. Okay. So make sure you record, and record fairly detailed. Don't just write, like solid white crystalline. You might want to be a little more descriptive. What do the crystals look like? Are they especially big? Are they have a weird shape? Are they especially small? Are they circular? What are they? Okay. Make sure you got good, detailed observations for the observable properties. Okay. Once that's done, and again, for the smell test, you don't want to do that over this depression plate because you're just going to smell them all. Okay. Because you're not going to get one or the other because it's too close together. Go and smell the original samples. Guys, there's only two that have any smell at all, and only one where the smell is really important. Okay. Once you've done the observable properties test, the next test you're going to want to do is solubility. Okay, so you're going to add some distilled water from your wash bottle, okay, into each depression. Okay, you do have to be mindful with the wash bottle. If you squeeze it hard, it's high pressure. If you just squeeze it a little bit, drops come out. Drops would be better. Okay, high pressure tends to shoot stuff out of the depression plate, and then it's hard to do tests after that. All right, so solubility would be next. Okay, you guys decide on how you want to instruct people to do that, but I've told you, you probably want to fill this to about 2/3 of the way full with water. Now, does that mean you're going to have enough water to actually dissolve everything? No. Even if something is highly soluble, you're not going to get it all to dissolve in this small of a space. So what are some things you need to look at in terms of signs that it might be dissolving? Do things look different when they start to dissolve? Okay. What will happen to the shape of if it's crystalline, what will happen to the shape of the crystals? Yeah, softening the edges, exactly. They'll be less sharp on the edges, they'll kind of dull, and if it's a colored crystal, the solution will change color, indicating that this stuff has dissolved. So those are things to watch for, right? If something's floating on the top, doesn't seem to be changing shape or shrinking or doing anything like that, then it probably isn't soluble. Okay? And you really are only going to have a couple that are obviously not soluble. Okay? Follow in there on the solubility test. Okay? Now, when you write your observations for the solubility test, you'll want to, again, write a bit of a description. It's not a yes or a no answer. Okay? Seem to dissolve easily, solution changed color to blue, stirred a lot, didn't seem to dissolve very much. And during the solubility test, you're also going to want to be taking the temperature. At least two of these will have temperature changes during the solubility test. One is going to get slightly colder, one is going to get hotter. Okay, and there's a possibility of a third that may slightly increase in temperature, but you're going to have two temperature changes for sure that you will observe, okay, and they will need to be recorded during the solubility test. Okay. All right. The next test after that, now we have a solution in every single depression. What should we do with that solution? We should do the conductivity test. The observations for this one are easy. Push the button, stick it in there, and record the number. Okay? Be a little more detailed than that in your procedure, but that's really all there is to that test. It's quick and easy. Okay? Last test we do, pH. Why do we do pH last? When you stick the pH paper in there, what's the pH paper going to do? It's going to change color. A color change is an indication of what? A chemical reaction. That's what happens when you use pH paper. There's going to be a chemical reaction. After this test, your sample is contaminated. And it isn't truly that sample anymore. Not to a huge extent, but probably nothing that would really interfere with what we're doing. But after this test, we can't be certain anymore. So we have to do it last because it does involve a slight chemical change. Okay, so pH test, put the strip in, compare it to the color chart, record the number. So all your observation is going to be for that is, again, a number. Right? So two of the tests you don't need very much room in your chart for. Okay? Conductivity and pH don't need very much room. Observable properties needs the most room, solubility the second most. Okay? All right, those are your tests. Not many of them. Okay? It shouldn't take you too long to do the lab on Monday. Okay, everybody clear on that? Now, we ended off yesterday talking about the hypothesis, and I got all the way through if, and then with you guys, right? Okay. So then you got your materials here, and I think I told you yesterday, on the materials list are all of the unknown compounds. We do need to make 2 changes, okay, to the unknown compounds. The first one has to do with cobalt chloride. It's not going to be cobalt 2 chloride, it's going to be cobalt 2 nitrate. Okay, so it's now going to be CONO3 2. Okay, and same with nickel. Okay, nickel is going to change from nickel 2 chloride to nickel 2 nitrate. Okay, so it won't be NiCl2, it'll be NiNO3. We simply could not get those 2 things, they were backordered. So it'll still be the same metals, but it would not be quite the same compound. It's not going to really change anything. If I hadn't told you that, you'd have probably still been able to identify them correctly. Okay. Nickel 2 nitrate, yeah, and cobalt 2 nitrate. Okay, the rest of this stuff is as it appears. Okay, they are all in there because I made them all up last night. This stuff here is probably not something you guys have ever dealt with before, at least not that you knew. Okay, ammonium nitrate is commonly used in commercial first aid cold packs. Okay, how many of you ever used one of those where you pop the bubble in the middle, shake it, and it gets cold? Okay, what's in the bubble is water. And the powdery stuff, the stuff you can hear shaking around in there, is ammonium nitrate crystals. When they come into contact with water, they are highly soluble, but they get colder. Might be useful when you're trying to identify your compounds later. Okay. All right. So what basically you and your group need to work on today is the design of the procedure. Okay, I mean, you might get a chance to talk about your hypothesis and design and all of that, but we talked about it yesterday. Okay, you guys need to come up with a procedure, step by step by step. Suggestions for that. Okay, obviously, first off, it needs to be a numbered list. Okay, but can you say, can you describe each test, and then at the bottom of the list of tests say repeat steps like 4 through 11 for all compounds? Good, do that, because I actually have had people hand in lab reports that are 12 pages long because they've actually written the steps for each, they're exactly the same, but they did it for each compound. And there's really no reason to do that, okay? Just say repeat steps for each compound at the end, all right? Also include things like how you set it up, okay? So, acquire the materials, tell them again how much to put in there. Make sure you're telling them what observations to make at each step. And then at the end, a remark about cleanup. Okay? All of the samples will be washed into the waste bucket and not down the sink. Okay? You cannot put nickel and cobalt down the sink because they're heavy metals. Okay? And if they get into the water system, they're toxic. Okay? So that's probably something you'll want to include in there, is that no samples should be rinsed down the sink. They shall be rinsed into the waste bucket. Okay. Mention something about washing up all of your materials and drying them and putting them back. Okay. Those are also things that I look for in the procedure. Okay. Questions on that? All right. For the analysis, obviously we can't do that yet. Okay. We won't be able to do that until we have all of our data. But all you're going to have to do is identify whether it was ionic or molecular, and then tell me A was water, B was whatever. Okay, and then for your conclusion, copy and paste your hypothesis. We talked about that before, and then tell me, were you able to do what you said? What does your data say? Okay, did your data say something about everything being unique? Okay, and talk about that. Okay, evaluation, your 2 sources of error. One of the sources of error may have to do with the size of this. Something to think about. Okay, by this I mean the depression plate I'm holding right now, because if you're watching the podcast, just hearing me say this won't mean anything. Okay? And then for the class discussion, don't do those. Okay? Don't answer the class discussion questions. We're going to go through those together when I hand back your labs. Okay? And when I say hand back, I mean like return electronically. I'm not don't print anything, right? You're just submitting it to me on Google Classroom. All right. Biggest group size, 4. Okay, more than that, and it gets crazy around the lab stations. All right, so find yourself groups of 4. If somebody doesn't have a group, let me know, and I'll make sure that you have a group. Okay, you guys can sit together today and get working on this stuff. You've got today's class to work on it. Let's use our time effectively.